Today we're going to look at key features of the functions, and we've actually talked a lot about key features of a function already, but we're going to add in the last few pieces of the function. But some of them that we're more familiar with, based on our first example here, the graph of y equals f of x is shown, graph to the right. Some of them that are more familiar are something like the y-intercept. Do you know what the y-intercept of this function is? And somebody says 2, and I'm going to be a little bit more specific than that. It's the ordered pair is 0, 2. The y-intercept is where the graph crosses the y-axis. If we can find the y-intercept, hopefully we can find the x-intercepts in letter B. As we look, we should notice that there's more than one x-intercept. Alexia?
Do you want us to put the 0 even though the y-intercept is always going to be 0?
So now, when we state the x-intercepts of the function, if the y-intercept is where the graph crosses the y-axis, the x-intercepts are where it crosses the x-axis. And it looks like we have a value at 1, 2, 3, 4, 5, negative 6, 0. And there happens to be one more over here at 1, 2, 3, 4, 0. There's another name for x-intercepts. Do you know what it is? And I'm not sure that I would have remembered it. One try? Not slope, but good try. They are called zeros of the function. Sometimes I use the word roots of the function. I'll put the roots in parentheses. That's my word. It does also mean an x-intercept or a 0 of the function. And those are pieces of the function or features of the function that you're familiar with. But there's more to this graph, and in fact I'm going to erase those points that I just put on there just to take them out of confusion. We read math from left to right. So when we're reading the graph, we still read the graph from left to right. And when our graph is going up, going in the upward direction from left to right, what we do is we say that the graph is said to be increasing. And when we identify the increasing on here, what we're doing is we're identifying where it's increasing. And that means we look at the x values of our points to identify that. I'm going to say that one more time. When we're looking at where our graph is increasing, or even where our graph is decreasing, we're looking at the x values of the point. So when we start here on our graph and we look far to the left, we've got kind of a blue-looking point there. But what's going to happen is we're going to go up, 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 till we get to the very top of that graph, that part of the graph there. The x value of our blue point at the far left of our graph is 1, 2, 3, 4, 5, 6, 7, negative 8. We're going to fill that in our first blank there, negative 8. And we went, and I tried to go to this point here. We want the x value of that point because in between those two values is where we're increasing. So the x value of that red point that I just put on the graph is 1, 2, 3, negative 4. So where our graph is increasing is between negative 8 and negative 4. Well, that's not the only place where we're increasing. But what happens is, on this graph again, we went up, 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 up. We got to the very top there, and I didn't want it to be a line, but it turned into a line there. Then we went down, 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 down. Then when we get over here again, and over here, starting at this point, we start going up, 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 up. Again, not supposed to be a line. The highlighter is becoming a line for some odd reason. But where we started going up is we started at this point right there, up to this point right there, and we want the x values of those 2 points. The first value is -1. Remember, we're going from left to right. And then over here at 2, the ordered pair of that very, very high point on the graph, the x value of that is 2. And it seems that we have one more place where we're also increasing. And once we get to that top of the blue, we start going down, 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 down. But then we finish with going from here to here. Sorry, it didn't highlight. But from there to there, we started going up, 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 up. Didn't go very far. But we want the x value of our green point right there to the very ending point. And the x value of our green point is 1, 2, 3, 4, 5. And then our ending point on our graph happens to be at 6. Looking at the x values where our graph is increasing. But like I said, we don't just increase on a graph, we can also decrease. When our graph is going downward from left to right, it's said to be decreasing. And whether it's increasing or whether it's decreasing, we still are asking ourselves, or looking at the x values of the points where it's decreasing. So in our first situation, and we saw that earlier, when we started, we went up, 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 up. We got up to that high point there on the graph, and then we started going down, 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 down. So we went from a high point on the graph to a low point on the graph. In between those 2 purple values is where our graph is decreasing. And we identify that place with the x's. 1, 2, 3, -4, and then -1. Those are the x values in numerical order of that point, of where it's decreasing. Those 2 purple points, that's where it's decreasing. When we get to the low purple point, we start going up, 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 and we get to this high point here. But then once again, we start going down, 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 and down. From the high point to the low point, which happen to be orangish in color, that is where we are decreasing again. And we identify those points with our x values. So from 2 is our high point x value. Over to 1, 2, 3, 4, 5 is our low point x value. And in between 2 and 5 is where our graph is decreasing. Well, there's a couple more pieces of information about our graph. And again, I'm going to go ahead and erase the graph one more time. But there's something called an absolute maximum and an absolute minimum on a graph. The absolute maximum is the highest point on the graph. Nothing higher. And the absolute minimum is the lowest point on the graph. Nothing lower. When we take a look at our picture once again, what we see is that this point, as I'm trying to mark it right now, that's the highest point. Nothing higher on the graph. The highest point on the graph, we want to label that. So I'm going to put A, B, S, M, A, X. Absolute max. Its ordered pair is 2, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. We actually have a very low point on the graph. And our lowest point on the graph is this point at the far left. That's our absolute min. And our ordered pair for that point is 1, 2, 3, 4, 5, 6, 7, 8, negative 8. And 1, 2, 3, 4, negative 4. Absolute max, absolute min. The highest point on the graph or the lowest point on the graph. You don't have to have an absolute max or a min, or you could have one. It just depends on the graph. There's also something called a relative minimum or a relative maximum. Relative minimums or relative maximums occur at peaks or valleys on the graph, or where the graph changes direction. So one more time, I'm going to erase my picture. But this first one, if I can get it graphed here, this first is a peak right there where I just put the red dot. And that is a high point on the graph. It's not the highest point of the graph, but it is a high point of the graph. It's a peak of the graph, and its ordered pair is 1, 2, 3, negative 4, 1, 2, 3, 4, 5, 6. And it's a relative maximum. It's a maximum. It's not the highest, but it's a high point of the graph. There's actually one more relative max, which you have labeled on your paper as the absolute max. It's both in this case, and that point we said was 2, 8. That's a high point of the graph. But we have a relative min or 2 also. And we have a minimum at this purple colored point here. Its ordered pair is negative 1, 1. It's a low point of the graph. It's not the lowest point of the graph, but it's a low point of the graph. We also happen to have a minimum at this point over here, kind of to the right. And it is 1, 2, 3, 4, 5, negative 2. Finally, we want to identify the domain and the range. Again, something that we've been working with that we are more familiar with. When we're dealing with domain and range, if this is a topic that's causing you trouble still, draw a rectangle. And we can draw a rectangle on this particular picture because we have a definite starting point and a definite ending point. So we're going to draw a rectangle. So we just do the rectangle around the graph. Again, we can draw that rectangle because we have a starting point and an ending point. We don't have arrows at the end. The domain goes from the point farthest to the left and then farthest to the right. So it's going to go to the left side of the rectangle to the right side of the rectangle. And we go 1, 2, 3, 4, 5, 6, 7, -8 spaces. And then 1, 2, 3, 4, 5, 6. -8 to 6. Those are points that are on the graph. The range goes from lowest to highest. Our lowest value is 1, 2, 3, -4, the bottom of the rectangle, to the top of the rectangle. 1, 2, 3, 4, 5, 6, 7, 8. Let's try another one. You've only seen one example with a lot of information in it. And here we're just going to look at some of the new stuff for us, which is relative minimum and relative maximum. And remember that relative minimum and relative maximum occur at a peak or a valley. So there happens on this particular problem to be 3. Here's a valley, here's a peak, and here's another valley. So those 3 points are going to be either relative minimums or relative maximums. As we look far to the left, it's a valley here, and the ordered pair is 1, 2, -3, 0. Also happens to be an x-intercept. Well, when we go to the middle green point, that is a peak. That's going to be a maximum. Happens to be the y-intercept as well on the graph, and this is 0, 3. But we also have a point to the right, again at a valley. Its ordered pair is 1, 2, 3, -3. And it's going to be a relative minimum. Not a max, it's a min. I don't know if I want to put square brackets on there or not. Maybe I'll write smaller. -3, 0. And +3, -3. There, that's better. Now, relative doesn't have to be the highest point or the lowest point, but absolute value does. Or absolute max or min has to be the highest or the lowest. The minimum, absolute minimum, has to be the lowest. And I'm going to color that in red. That's the very lowest point on the graph. An absolute min or an absolute max does not have to occur at a peak or valley. But it just so happens that it does, and it also happens that it's a relative minimum as well, and it's 3, -3. The maximum, the absolute maximum, the highest point in the graph, is the y-intercept, which is 0, 3. So not only is it a relative maximum, it's also an absolute maximum. And now what we want to look at is, where does our graph increase and where does our graph decrease? And remember, read the graph from left to right. So as I start over here, I'm going to start here, where my cursor is on the graph. And notice that as we take the cursor and go down, 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 we're going to start here by decreasing. When we identify a place where it increases, or we identify a place where it decreases, we use the x values. And our point that's farthest to the left, 1, 2, 3, 4, 5, is -5. Down to our green point that's farthest to the left of 1, 2, -3. That's where our graph decreases. Well, when we get to that green point, we start going up, 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 up. So here's our green point. We're going to go up, 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 up. When we're going up, 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 we're increasing. So where we're increasing in this case is from the x value of our green point, which is -3, to the x value of our y-intercept, which is 0. It's our first red point on the graph. I think I'll change colors here and make this next point purple instead of red. Because now, from the red point to the purple point, we start going down, 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 down. There's a decreasing value again. And when we decrease, we're going to identify where it's decreasing by the x values of our ordered pairs. 0 to the x value of the purple point, which is 3. And then if we finish this, I'll fill in that colored point there. And when we finish, we're going to go from the purple point to the black point. We're going up, 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 up. And the purple point has an x value of 3. And our black point has an x value of 5. So our last example here, as we turn the paper over. Hopefully each time we do an example that you're getting more and more of an understanding. And this one, we have a lot of even our previous information in it. First and foremost, is this graph a function? And luckily, some of you are nodding yes, which it is. Is it one-to-one? No. Y-intercept. What's the y-intercept in this graph? Well, it's not particularly labeled, but if we look here, I want to pick a different color actually. There's our y-intercept. And it looks like it's 0, -2. Part C. Zeros of the function. Remember that a 0 of the function is an x-intercept. And if you've forgotten that from the front of the page, then that's something good for you to write down. But we're going to have to approximate these values here. As I start to the far left, and you don't have to start to the far left, but you just want to make sure that you have them all listed. But I'm going to start to the far left. And it's 1, 2, 3, a little bit more than 4 here. So I said it was -4.25, 0. Then I said it is -2, 0. It's really close. And again, we're having to approximate these. So it looks like it's 1, 0. And this one is darn close, 3, 0. And there's one more. 1, 2, 3, 4, I said 4.75. 0. Now you might have a little bit different interpretation, but you want to be close. I would not say that that last x-intercept is 5, 0 though. It's something less than 5. Now, notice on this graph, and I kind of covered it up in here, but we want to state the domain and the range of the function in interval notation, and on this particular graph, which is different from the front page, we have arrows at the end. What do you think our domain is going to be because we have the arrows? Negative infinity to infinity. Which is true. But the range may or may not be. Do we have a high point or a low point in the graph? And in fact, this kind of gives away another question, but do we have an absolute maximum or an absolute minimum on this graph? And we actually don't. And because there's no absolute max or no absolute min, our range is going to be also negative infinity to infinity. Let's jump down to G and answer that question, which was, is there an absolute max or min? There isn't. How can we check? Michael? The arrows indicate that the graph goes on forever. But as you write that down, what I often say for the range is, do we have a high point? Do we have a low point in the graph? If we do have a high point or a low point in the graph, our range is not going to be negative infinity to infinity. So we've answered a lot of questions. We still have where is it increasing, where is it decreasing, and our relative mins and maxes here. So when we start this graph, we read it from left to right. So even though the arrow is pointing downward, if we were to draw this graph, we would start drawing it going up, 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 up. And because we start drawing it going up, 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 our first interval means that we're going to start from negative infinity. And we're going to go to the x value of this purple point right there. And that x value of that purple point now is negative 3. But once we get to that purple point, I need to come up with a better one here. I don't know what to call that, kind of the sea blue point. We start going down and down and down and down until we get to that sea blue point. Because we're going down and down and down and down, we're decreasing. We're going to say that negative 3 is less than x is less than negative 1. But once we get to that sea blue color, we start going up, 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 up. And up means that we're dealing with increasing. And we're going to increase from negative 1 to 2. Second purple point there that I will fill in. From negative 1 to 2. But once we get to that second purple point, we start going down and down and down and down and down. And we have another C blue point. Down and down and down and down. This means that we're decreasing. We're decreasing from 2 is less than x is less than 4. Again, writing these numbers from left to right, as well as reading the graph from left to right. But once we get to that sea blue color, our graph starts going up, 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 up forever. As you said for our absolute maximum and minimum question, we keep going up. So this is going to be 4 is less than x is less than infinity. As we finish this problem here, we want to identify any relative minimums and any relative maximums. I have lots of colors on the graph. Can you identify any relative minimum ordered pairs? And think about it in your head if you don't want to answer. But one of the relative minimums that I see is at -1, -3. It has the C blue point on it. I'll mark it again in a different blue. There also happens to be yet another C blue point that I'll change it to a lighter blue at 4, -1. Once we identify those values, we need to finish by identifying any relative maximums. And our relative maximums both happen to be at the purple points here, which are -3, 2. They're at peaks on the graph, and 2, 1. They aren't the highest point on the graph because we have an arrow that continues going in the upward direction forever and ever. Or our relative minimums aren't the lowest points because we have an arrow going in the downward direction that continues on forever. But we do have some relative maximums. High points on the graph, not just the highest point.